This video will cover the solubility curve and how to answer questions based on the graph itself. So we're going to talk about a couple of terms, unsaturated, saturated, and supersaturated. So we want to be able to differentiate between those. And then we're going to look at a graph called a solubility curve and talk about how we can use that graph to just determine how soluble something is. So in general, when we're talking about solubility, we can use a few different terms to describe that. So when we say something is soluble, right, we're saying essentially how much dissolves. So if we say something is more soluble, that means it dissolves well, right? So like sugar, for example, right? Sugar is very soluble. It dissolves in water. So if we're talking about an unsaturated solution, okay, that means that I can keep adding solute and it will keep dissolving. Okay, so that means there's not very much solute. Okay, so if you're thinking about like putting sugar in water, you add the sugar, you stir it up, it dissolves, right? If you can add more, stir it up, and it also dissolves, like you can just keep on dissolving, that means you have an unsaturated solution. Saturated solution is where we kind of have this accumulation of the solute at the bottom. So if you've ever noticed, if you're adding sugar to water, at some point it gets where no more will dissolve. And that's because it's reached that saturated point where the water just can't hold any more dissolved compounds. Our supersaturated solution, this is kind of an exception to the norm where we have your solute becomes kind of crystallizes. Okay, so the way that we make a supersaturated solution is we usually have to do something to it. So typically what we do is we increase the temperature. Temperature makes it easier for solutes to dissolve. So if you think about like if you've ever made like sweet tea at home, or if you anything where you kind of have to heat it up, you know, the sugar dissolves really easily, right, when we heat something up. We don't even really have to stir it. It just dissolves because it's in hot water. If I start to cool that water back down, though, sometimes I can see that kind of crystallization of the solute. This is how we make rock candy. If you've ever seen that at the store, you can essentially make rock candy at home because all you do is you boil water, you put a whole bunch of sugar in it, more than it would naturally be able to dissolve. But remember, we've increased the temperature, so we've made it easier to dissolve. And then as you let that water cool down, then the sugar crystallizes out because, again, the water isn't really comfortable holding that much sugar. So we call that a supersaturated solution. We've actually put more sugar in there than that water could normally hold. So here's an example of our solubility curve, okay? And really, all we're doing here is we're just comparing the temperature of our typically water, right? Remember, water is our universal solvent. That's usually what we're using to dissolve things. So we're talking about the temperature of our water, and then our y-axis is measuring how much we can dissolve. So that's our grams of solute. Of solute. Okay, so that's going to be how much of that sugar or salt or whatever it is that we're trying to dissolve. If we have a substance, essentially when we're looking at the graph, if we are looking at that line, so right on the line, we call that a saturated solution. If we have something below the line, we call that unsaturated. And then above the line, we call that supersaturated. Okay, so just make sure these terms are written down in your notes, and then we'll go through some examples so you can kind of see what we mean by these words. Okay, so first let's just get kind of comfortable using the graph. So for this question number 1, it says, what mass of solute will dissolve at the following temperatures? So again, we're always talking about this whole graph is about 100 milliliters. So the volume doesn't really matter in this case. We're talking about this graph is made specifically for 100 milliliters. So all we really have to do is we just have to find what it is we're looking for and then find the temperature. So I'm going to find potassium nitrate, or KNO3. It's right there. And I'm going to find 70 degrees, which is right there. And so all I'm going to do is find, it wants to know what mass. So I'm just going to follow my temperature line up until I connect right with that KNO3 line. And so that point that I connect, if I go all the way over to my y-axis, that is my answer. So 130 grams of solute will dissolve in water if that water is at 70 degrees. Okay, for the next one, NaCl, that's just table salt, and 100 degrees. So let's see, actually, let's change my color here, and we'll hopefully be able to see the difference here. So NaCl, that's this line right here. It's kind of almost flat, but it increases just a little bit. So here's our 100 degrees. So again, we're just going to go up until we meet that line, and we meet it right there. And that is pretty much right on that 40 grams. So that means 40 grams of salt will dissolve if that water is at 100 degrees. Let's look at the last one. This is ammonium chloride, NH4Cl, and then 90 degrees. So let's see if we can find it, and it's right here. Okay, so sometimes it's easy if we trace that little line there. And then we're at 90 degrees. So again, we're just going to go all the way up until we intersect with that line. And then we'll just go straight over. And we're right at 70 degrees. So what this graph is saying, right, our lines, that's just telling us how much we can dissolve at that temperature. That's telling us like the maximum, ideally. So if you notice, almost all of these, I'm going to erase some of this so you can see. Almost all of these lines are going straight up. There's a few exceptions. This line is going down and this line is going down. Pretty much every other line, if we kind of just use like a different color, we can see almost all these lines are going upwards. Even some of them, they might not be going up very much, but they are increasing. Anything that is increasing, these are all solids. Okay, so I'm just going to kind of put a little line, right? All our lines that are increasing, these are solids. So typically a solid is going to be more soluble. Solid, we'll just write it down so you can write it down. More soluble at high temp. So the hotter it is, the more soluble. These lines, these are gases. So gases, they tend to be less soluble at high temps. Okay, so if we look at this last question here, for D, it says, which of these above 3 are the most soluble in water? So let's kind of, we just want to talk about these few that I'm going to kind of get rid of all these other lines. So these are our 3 substances that we were talking about in our question, right? We have potassium nitrate, sodium chloride, and ammonium chloride. And it wants to know which of them is most soluble at 15 degrees. So 15 degrees is right in here. So let's see, which one can I add the most, right? Which one is going to be the highest at 15 degrees? And it looks like this one right here. And that is my NaCl line. Okay, so remember, most soluble means more can dissolve. Okay, and since that line for sodium chloride is higher, that means it's the most. Okay, let's look at one more of these. We'll do this one right here. Okay, B. Right, so for this one, we're going to look at this whole graph. Okay, and I think this one isn't actually on your notes, but this will just be good practice. So for B, it says, which is the least soluble at 40 degrees? So we'll find 40 degrees, right? Remember, least soluble means we can dissolve the least amount. So let's see which one is the smallest amount. And that's just going to be this very first one we get to because it's the lowest. So that means this guy is the least at 40 degrees, least soluble. Okay, see if you can answer C, which is the least soluble at 10 degrees. So here is 10, and again, we're looking for least. So we're just going to be this guy right here, which is potassium chlorate, KClO3. You may have a question. I'm going to kind of scroll back up to this graph quickly. You have some questions on the back of your notes, some practice. And they're asking you things like identify that saturated, supersaturated, or unsaturated. Okay, so let's look at a quick example. Let's say I'm talking about, let's use this NaNO3. Okay, this is my substance that I'm talking about. And let's say that I have 80 grams at 40 degrees. Okay, so I have 80 grams at 40 degrees. So I find my intersecting point there. Okay, notice this dot is below my line for NaNO3, right? It's below. So that means this is unsaturated, okay, because it is below the line. Right? Let's say that instead of 80 grams, what if I had, let's find another one that looks good. Let's say I had 80 grams at 10 degrees Celsius. Okay, so we find that intersecting line there, 80 grams at 10 degrees Celsius. That dot is right on that line, so that means this is a saturated solution. That's exactly how much I can add at that temperature. So that means it's saturated. Okay. If you have a dot above the line, let's say here, let's say it's 50 degrees Celsius, right? So we've gone up and it's 140 grams. Okay, so this is our kind of intersecting point here. If I have 140 grams at 50 degrees, this dot is above the line, so that makes this a super saturated solution. Okay, so for the back part of your notes at the top, it's going to ask you, is it super saturated, saturated, or unsaturated? And it's your job to try to identify where that is. Okay, you may also be asked, how much do you need to add in order to make it saturated? So let's say we're looking at this dot here, right? We know we have an unsaturated solution. And I want to know how many grams do I need to add in order to get to that saturated. So I just want to know what's the difference between this dot and this line right here, right? I want to know, what is this space? How much do I need to add? How much do I need to keep going in order to get to saturated? So this looks to be about right in the middle, which I would say is maybe 105 or so. So if we're at 80, right, this is our dot right on this line, we're at 80, and we have to go up to 105, that means we have to add 25 grams in order to get to a saturated solution. So at this point, go ahead and try to answer the rest of your questions on your notes. And if you have any questions, make sure you let me know.